Hi and Assalamualaikum to everyone. My name is Masturina Amalia Binti Marlizan. My metric number is 2013928852. I'm from UR65230008. Today I want to present about Lab 2 NMK21303 Analog Electronic 2. The topic of this session is operational amplifier, inverting and non-inverting amplifier. In this video, I want to talk about op-amp. Here you can see the symbol of the op-amp. An op-amp is a short of an operational amplifier. Op-amps are basically high gain differential amplifiers. This device they amplify the differentiate the input voltage of V1 and V2. Now the op-amps has very high input impedance but a very low output impedance. The negative terminal here is known as the inverted input. So if you apply a signal to inverting input, the output signal will be 180 degrees out of phase with them. The positive terminal is the non-inverting input. So if you apply a signal there, the output signal will be in phase with the input signal at V2. So here is a basic circuit diagram of an inverting amplifier. The signal is applied to the inverting input, which is represented by pin 2, and so the output will have the inverted signal. RF is known as the feedback resistor. This resistor takes some of output signal and feeds it back to the input. So as a result, it reduces the voltage gain. Now when you have a feedback resistor, the voltage gain is said to be a closed loop voltage gain, and that gain is equal to RF divided by R1. On the input resistance, now of course because of the signal has been inverted, we need to put a negative sign here so that I can calculate the gain for this particular circuit. The value of 4.7K, 10K and 33K in the table. Now you can see the value of calculate and experiment of AV and Vout. Here the inverting operational amplifier of 4.7K, 10K and 33K. Now look at the graph. Okay, now let's go over the next type of circuit, which non-inverting amplifier circuit. So here we are going to use the 741 op-amp move time. So this will be the positive terminal and this will be negative terminal. So notice that I flip it. Now we are going to apply the input signal to the positive terminal. So because it's a non-inverting amplifier, the output signal will be in the same phase as the input signal. It's not going to be inverted. Now we are going to have a V in between pin 2, that is the inverting input, and the ground. So let's call that the input V in. We are still gonna have out feedback resistor between input 2 and 6. So notice that if you compare this circuit with the inverting amplifier circuit, the feedback resistor was still between pins 6 and 2. So that hasn't changed. Now let's not forget to put the supply voltage. So positive V and negative V. for pins 4 and 7. Now the closed loop voltage gain for this particular non-inverting amplifier is still the feedback resistor divided by the input resistance, but with an addition of 1. So it's same gain as the inverting amplifier, but adding 1 to it as well. So that's how you can calculate the gain for this particular circuit. On the table, you can see the 4.7K value of calculated experiment of AB and V out, and also 10K and 33K. Here the graph of non-inverting operational amplifier of 4.7K, 10K and also 33K. Okay, that's all from me. Thank you.